Chapter 12 Publishing Documents Using LaTeX. We have learned how to use OpenOffice.org Writer to create documents. In this chapter, we shall discuss the text and LaTeX typesetting software. We shall discuss the advantages of using LaTeX. Then we will learn how to use LaTeX using TextLive, a software package of the text LaTeX software combination along with the SCITE text editor. Using LaTeX. To use LaTeX, we need any LaTeX distribution, that is software. Most include text and some additional software in them. TextLive is a very popular LaTeX distribution available in the standard Ubuntu repositories. We also need a plain text editor and software to view the output file. LaTeX can produce output in different file formats, and depending on the output file format, corresponding viewer software is needed. LaTeX documents are typically created using any plain text editor like gedit or SCITE. The different parts of the text are marked using LaTeX commands that associate a meaning to them. For example, \title is used to define the document's title, \author to specify the authors of the document, and \date to indicate the date the document was created. Similarly, \chapter, \section, \subsection, \paragraph can be used to explicitly specify the logical structure of the document. LaTeX comes with built-in ways to format these document elements in a pleasant-looking professional style. However, when typing the document, we will only see it as plain, unformatted text, with these commands written as part of the text. The document is then compiled, that is processed, using the LaTeX system, and an output file is produced. LaTeX may also produce some additional files. In most cases, these additional files can be deleted safely without losing any information. When we view the output file using appropriate software or print it on a printer, we see the formatted document. If we are not satisfied with the looks of the document, we may customize the built-in styles or define our own styles. Every time we make some modification in the source text, we need to compile it again for seeing the effect of our change on the output document. Both text and LaTeX use the file extension .tex. LaTeX now has a command called PDF LaTeX that produces the popular PDF, that is portable document format files. PDF files can be viewed on screen as well as printed to printers, and the printout looks exactly same as the monitor display. PDF files are very popular for sharing printable documents on the web. PDF documents can be viewed in Ubuntu's default document viewer, Evans. Hence, the edit compile view cycle becomes edit the document using any plain text editor like gedit. Compile the document by issuing the command PDF LaTeX file name at the command prompt in the directory where the text file was saved. View the generated PDF file by either opening it from the GUI or by issuing the command Evans PDF file name at the command prompt, that is, the terminal will display the next prompt only when you close the PDF file. We may also use the SCITE editor for editing LaTeX files. While both gedit and SCITE have syntax highlighting, that is displaying different language elements in different colors for easy identification and readability, SCITE has one advantage over gedit. One can compile and view the document from within the SCITE program itself. As you are already familiar with SCITE, we shall use SCITE as the editor for learning LaTeX. To use SCITE with PDF LaTeX, we need to make changes to its configuration file as shown at the end of this chapter. The user needs to perform the operation only once after installing the required software. The LaTeX language. LaTeX is essentially a markup language. The LaTeX source consists of plain text with some parts of the text marked up using markers known as commands. Some commands are independent commands. They do not mark any specific part of the text. These commands can perform a variety of tasks. When the document is processed by the LaTeX system, they may provide information about the text or the document. They may indicate the role of the marked text in the overall structure of the document and hence cause LaTeX to format the text in certain way. They may directly specifying formatting, or they may instruct LaTeX to process the document in a certain way. For example, use a certain page size, start a new chapter only on an odd numbered page, etc. LaTeX commands start with a backslash character followed by the command name. The command name may be a string of alphabetic letters only or may be a single non-letter. LaTeX commands are case sensitive, that is, capital and small letters are treated as being different. Some commands may accept additional information. For example, the backslash text color command expects the color in which the text is to be displayed. This additional information is called arguments. There are two types of arguments. Optional arguments, as the name suggests, are not mandatory. We may or may not provide them. If we want to provide one or more optional arguments, we write them after the command name enclosed in square brackets and separated by comma. These are followed by mandatory arguments if there are any in curly braces, with each mandatory argument written in its own set of curly braces. For example, if we issue a command \document class in square bracket 12pt in curly bracket article, then document class in the name of the command 12pt is an optional argument while article is a compulsory argument. LaTeX treats all whitespace characters, that is the space, tab and new line characters, as the same. It converts all occurrences of multiple consecutive whitespace into a single space character. The white spaces at the beginning of a line are generally ignored and one or more consecutive blank lines are considered to mark the beginning of a new paragraph. This means that even if you type your text as several lines, it will appear in the output as a continuous flow unless there is a blank line in it. To insert a break in lines, use the line break command at the end of each line except the last line in the paragraph. Figure shows an example of continuous text as well as how to insert explicit line breaks. We shall discuss the \text sf command later. Figure shows the output of the LaTeX file. The following characters are reserved characters in LaTeX: hashtag, $, percentage, and underscore, curly brackets, caret, tilde, backslash. They have a special meaning in LaTeX. These characters cannot be used directly in our text in LaTeX. If we want to use them in our text, we must use the following forms: \hashtag, $, %, \and, \underscore, open curly bracket, curly bracket close, caret curly bracket, tilde curly bracket, text curly bracket. Note the special cases of the last three characters. The symbols greater than and less than print very differently by default except in Mac mode. Hence they must be written as \textless and \text greater. The grave ancient or backquote and apostrophe or straight quote are used around text to put it in single quotes like book code. Double quotes are produced by repeating them twice like book code. These are two straight quotes, not a single double quote. These may look odd in the source file, but are typeset properly in the output file. LaTeX uses groups to mark portions of text. A group is enclosed between curly braces, and any command in a group applies only to text following the command within that group. Also, some commands are followed by a group and apply to the whole group. Groups are useful for applying few commands to a small amount of text, such as a part of a line, few lines, or a paragraph. For the cases where a multitude of commands must be applied, for example, for formatting a table or mathematical equation properly, or where some commands have to be applied to large portions of the text, like several paragraphs, whole sections, LaTeX provides a facility called environments. An environment begins with a backslash begin in curly bracket environment name command and end with a backslash end in curly bracket environment name command. All the formatting characteristics of the environment are applied to the entire text inside the environment. Environments can be nested. We can have one environment inside another. There are several standard environments meant for specific types of content like equation, quotation, table, and lists that come with nice ready-made formatting commands for these specific content types. While LaTeX documents are meant to be displayed and printed, LaTeX has several advanced features, including programming and automatically generating parts of the documents or multiple documents, that is mail merge. Often a complicated LaTeX template or package developed by one person or team is used by many others. Sometimes those people also need to tweak the LaTeX code. In such cases, providing explanation for the complicated parts makes it easy for others to understand the code. Such explanation is provided in the form of comment. In LaTeX, the percentage character marks the beginning of a comment, and everything from the percentage character up to the end of the line is treated as a comment. Comments are meant for the humans who read the LaTeX source code in a text editor for understanding and possibly modifying it. They are completely ignored by the compilation process and hence never make it into the output. The structure of a LaTeX document. A LaTeX document has two parts, namely preamble and content. The preamble contains metadata, that is, data about data. In this case, the metadata is information about the document. For example, what kind of document it is, who is the author, when was it created, and instructions on how LaTeX should process the document. The actual content is always inside the environment document, written between backslash begin in curly bracket document and backslash end in curly bracket document. The preamble. As LaTeX supports creation of a wide variety of documents, each with different characteristics and format, LaTeX needs to know what type of a document used as a source file is. The very first element in the preamble must be backslash document class in bracket document dash class dash name, specifying the type of the document. Some common document classes are as shown in table. Many document classes have options. Table lists some common options. Document class article. Purpose for writing individual articles. Document class book. Purpose for writing entire books. Document class slides. Purpose for creating presentation slides. It automatically sets larger font size. Document class letter. Purpose for writing letters. Document class beamer. Purpose for generating presentations similar to office suites using the beamer package. Options 10 pt, 11 pt, 12 pt. Function sets the size of the main font in the document to 10 points, that is the default, 11 points and 12 points respectively. Options A4 paper, letter paper, legal paper. Function defines the paper size. These are several international standard paper sizes. The most common paper sizes in regular office use are A4, letter and legal. Options FLEQN. Function displayed formulas and equations are flushed left, that is left aligned, rather than centered, that is the default. Options landscape. Function changes the layout of the document to print in landscape mode. The document class declaration is followed by optional package declaration. While the LaTeX system itself provides for many common typesetting requirements, it also recognizes that it cannot provide everything that users may need. Hence, LaTeX allows users to write packages that provide additional functionality. There is a large community of LaTeX users who develop new LaTeX packages or enhance existing ones to cater to their own needs and then share them with others over the Comprehensive Text Achieve Network, that is CTAN. LaTeX distributions themselves usually come with a large number of such packages pre-installed. To use one or more packages in our document, we need to declare them in the preamble as \use package in curly bracket package-name. Some packages may also have options to customize their behavior. If we are not going to use options for any of the packages, multiple package names can be declared in a single \use package command, separate by commas. Table shows only a few of the commonly used packages. Package AMS Math. Description: it contains the advanced math extensions for LaTeX originally developed for the American Mathematical Society. Package Color. Description: it adds support for colored text. Package EasyList. Description: adds support for multi-level lists. Package Geometry. Description: for page layout tasks like setting paper size, orientation, margins, etc. Package Listings. Description: has special features for including programming code within the document. Package SetSpace. Description: lets you change line spacing. Three more pieces of information are typically supplied. They are as mentioned: \title in curly bracket, the title of the document, \author in curly bracket, authors of the document, \date in curly bracket, date of creation, /last update of the document in any format. It is necessary to provide the title and the author if you want LaTeX to create an automatic title for you. Providing date is optional. If it is omitted, then the date of completion is used in the title. These pieces of information can be supplied in the preamble or as the first thing in the document environment also. The document environment. The document environments for articles and slides will only have a title followed by the main content of the document. A title is automatically generated by LaTeX when it sees the \maketitle command. Of course, the \title, \author, and \date commands must precede the \maketitle command because their information is used in creating the title. A book can have a far more elaborate structure, though most elements are optional. The document environment of a book is divided into three main parts: the front matter, the main matter, and the back matter, denoted by the commands \front matter, \main matter, and \back matter respectively. This structure has things like the title, the table of contents, and the preface in the front matter, the bibliography, index, and references in the back matter, and the primary content in the form of chapters, sections, and subsections in the main matter. The main contents of a book has a hierarchical structure where a book is divided into parts, parts are divided into chapters, chapters are divided into sections, which are divided into subsections, which are divided into subsections, which are divided into paragraphs, which are divided into subparagraphs. These are marked with the commands \part, \chapter, \section, \subsection, \subsection, \paragraph, and \subparagraph respectively. Each accepts one compulsory argument, the title, and one optional argument, the title, to be displayed in the table of contents. They start a new part, chapter, or section respectively. The title to be displayed in the main text may be longer and may have internal formatting like boldface or italics applied to a part of the title, while the title to be displayed in the table of contents is expected to be short and devoid of any special formatting to maintain consistency in looks. These 7 elements nest inside one another and have an integer level assigned to them, with part having a level of 1, chapter a level of 0, section a level of 1, and so on. The parts, chapters, sections are numbered automatically by LaTeX. Hence, the author does not have to worry about it. The author can also move chapters, sections, and subsections without having to bother about renumbering. The parts are numbered in Roman numerals 1, 2, 3, and so on, while the chapters, sections, subsections, etc. are numbered in Arabic numerals 1, 2, 3, and so on. All chapters after the special \appendix command, to be used only once, are treated as appendixes and get uppercase alphabetic numbering A, B, C, and so on. Pages in the front matter are numbered using Roman numerals, while the pages in the main matter and back matter are numbered in Arabic numerals with the numbering restarting from 1. While both the front matter and back matter can have chapters like preface, acknowledgements, bibliography, those chapters usually do not have sections or other sub-elements. The commands defining different elements of the document also have their starred equivalents that are not numbered. For example, \section star can be used to create a section that is not automatically numbered. By default, elements are assigned number up to level 2, that is up to subsections. Subsections are further divisions are not assigned numbers. This can be changed by modifying one of the built-in counters of LaTeX in the preamble. For example, the command \setCounter in curly bracket sec numbered depth in curly bracket 3 ensures that elements up to level 3, that is subsections, are assigned numbers. Elements are assigned a number formed by appending a period in bracket full stop and the element number to the number of the parent element. Chapters are an exception as their assigned number does not have the part number and period in front of them. Chapters are assigned simple Arabic numeral numbers. If part 2 of a book has chapter 5 in it, which in turn has section 4 in it, that has subsection 1 in it, the subsection would be numbered 5.4.1. A well-formatted table of contents, that is TOC, is generated automatically from the element titles by LaTeX when it encounters the command \table of contents. Again, by default, a TOC has entire up to level 2, that is subsection, but this can be changed by altering the value of another built-in counter TOC depth. There is one important point to be noted. LaTeX processes the source file subsequently from beginning to end in a single pass. It produces the output file also subsequently. It cannot move back and forth in either of the file. This poses a problem. The TOC comes early in the document and must output their entries for chapters or sections along with their page numbers. However, at that point, LaTeX has no knowledge about chapters or sections that would follow. In this kind of situation, LaTeX must be run multiple times. In the first run, LaTeX collects information about the document structure and stores it in supplementary files. The TOC in the output files would be empty at this point or may have information from old supplementary files. In the second run, it will pick up the correct information from the supplementary files in the beginning to produce the correct TOC. Just like the TOC, LaTeX can also maintain list of figures, list of tables, cross-references, bibliography, glossary or index automatically. This offloads a great burden from the author's back and is a major reason for the popularity of LaTeX. Example: to have an idea of how LaTeX typesets books, let us create one source file and see its output. We will use the SCITE editor with LaTeX to work on the example. Create a new file in SCITE using the File to New menu option. Type the content shown in listing in a SCITE editor. Save the file using the File to Save menu option. Note that the extension of the file should be .tex. Now select the Tools to Build menu option. Shortcut key F7 to compile your LaTeX file. The output window will show several messages. If the last line, that is in blue color, reads exit code 0, then completion was successful. Otherwise, the error messages may point to the errors, but often they are difficult to interpret. If the completion was successful, you may select the Tools to Go menu option. Shortcut key F5 to view the file in the default document viewer. Don't forget to close the document viewer before returning to SCITE. Note that we have done some customization of the default book style in listing. Some of the features used are not discussed in this text. LaTeX typesetting is heavily customizable. Text formatting. In LaTeX documents, we type a paragraph in a continuous flow without pressing the Enter key. LaTeX then adjusts the text automatically. It decides how much text should go in the first line, how much text should go in the second line, and so on according to the page width, font size, alignment option used. LaTeX usually avoids breaking a word in two parts. Where it must do so, it has a hyphenation algorithm to decide the most appropriate way of breaking the word with a hyphen. For example, if the word formatting cannot be accommodated on a single line, the first line may end with format and the next line may begin with ing. On the other hand, there are some situations where some text, even though technically formatting multiple words, should not be split into multiple lines. For example, up to are two words, and yet it is not desirable to have one line ending in up and the next line beginning with to because up is an independent word with different meaning. So, the reader is surprised for a moment on seeing to on the next line. This is an obstacle to smooth reading experience. To avoid it, both up and to should be on the same line, either the first line or the second. In LaTeX, this can be taken care of by inserting a non-breaking space between up and to. LaTeX uses tilde character to denote a non-breaking space. LaTeX divides font families into three categories. Roman, also called serif. Fonts have a tiny line or curve called serif. At the end of the strokes, that is lines, sans serif fonts do not have serifs, while monospace fonts use equal width for all characters. Monospace fonts are typically used for computer code listings. The default fonts are Roman. These three types of fonts can be used for any text by employing the commands \textrm in curly bracket text, \textsf in curly bracket text, and \texttt in curly bracket text respectively. You can see the difference between serif and sans serif fonts in figure, where the section titles are in the default serif fonts while the body text is in sans serif. The font size can be changed using the commands \tiny, \script size, \footnote size, \small, \normal size, \large, in uppercase large, \huge, and in uppercase huge. Notice that the commands are case sensitive. The commands \textbf, \textit, and \emph can be used to add the bold, italic, and emphasis, generally same as italics, effects to text. \textsc provides small capital letters. Superscripts and subscripts can be created in text mode using the commands \text superscript and text, subscript respectively from the package FIX1 TX2E. Paragraph formatting. In LaTeX, the set space package provides the single space, one half space, double space, and spacing in curly bracket amount of spacing environments for setting the line spacing. By default, body text is fully justified in LaTeX. To achieve left alignment, right alignment, or center alignment, one may use the environments flush left, flush right, and center respectively. The first line of a paragraph is indented except for the paragraphs immediately following a heading. The backslash indent and backslash no indent commands can be used immediately before a paragraph to explicitly make the first line intended and unintended respectively. The verbatim environment outputs everything inside it, including special characters, spaces, new lines, and LaTeX commands, as it is without any processing. The moreverb package provides a listing environment with one mandatory argument, line, number of first line for program coding listing with line numbers. Page layout. In LaTeX, the geometry package can be used for page layout. The paper size and margins can be passed as optional arguments with the \usePackage command itself. Example, the command \usePackage in square bracket A4 paper, top 1 in, bottom 2 in, left 1.5 in, right 1 in curly bracket geometry. Sets the page size to A4, top margin to 1 inch, bottom margin to 2 inch, left margin to 1.5 inch, and right margin to 1 inch. Page sizes have been standardized internationally. The page sizes commonly used with regular printers are A4, letter, and legal. These can be specified by A4 paper, letter paper, and legal paper respectively. The page orientation can also be specified using the portrait, that is default, and landscape options. Documents can be either one-sided or two-sided. Articles are by default one-sided, while books are two-sided. Two-sided documents differentiate between the left, even, and right, odd pages and can have different margins for both to take care of amount of page space used up by the binding. There can also be rules like all chapters must start on an odd page. Typesetting mathematical content in LaTeX. Ability of automatically laying out complex mathematical content is a major strength of LaTeX. The most common way of laying out mathematical content in LaTeX is using the packages AMS Math, AMS Symbol, and AMS Fonts created by the American Mathematical Society. The AMS Math package defines several environments for mathematical content. There are two ways of typesetting formulas and equations. We may have them printed as part of the running text inline, or they may be printed independently on their own lines, called display in LaTeX parlance. The former form can be obtained using the math environment, while the latter can be obtained using the display math environment. The equation environment is a display environment that automatically numbers equations. A convenient way of appending math environment in running text is to enclose the mathematical content between $up to $. In the mathematical environments, each letter is treated as mathematical variable. Hence, they are different from the text environment. To better understand these environments, create a text file by using code in listing. Create a new file in SCITE using the File to New menu option. Type the content shown in listing in a SCI editor. Save the file using the File to Save menu option. Now select the Tools to Build menu option, shortcut key F7 to compile your LaTeX file. If the completion was successful, you may select the Tools to Go menu option, shortcut key F5 to to view the file in the default document viewer. Figure shows the output of the file when viewed in document viewer. Using mathematical symbols. Mathematics uses a large number of symbols. We shall discuss how some of those symbols can be used in LaTeX. Letters of the Greek alphabet have their corresponding commands like \alpha, \beta, \gamma, \pi that produce the lowercase letters. The same commands when used with the first letter in the uppercase. For example, \alpha produce capital Greek letters. There are commands for other mathematical symbols as well. Figure shows some LaTeX commands and the mathematical symbols produced by them using the AMS packages. The reason for providing commands for the trigonometric functions, sine, cos, and others are that they need to be recognized and typeset as functions rather than as individual variables. Using mathematical operators. LaTeX supports a large number of mathematical operators. The power operator x2 and the index operator x1 are not provided separately, but are implemented using the generic superscript operator, the caret character, and the generic subscript operator, the underscore character respectively. The superscript operator raises the text that follows it, while the subscript operator lowers it. Both reduce the size of the text as well. Absolute values can be denoted by enclosing the expression between two vertical bar symbols. Fractions are created using the command \fraction in curly bracket numerator in curly bracket denominator, while square root of a number x is denoted using the command \square root in curly bracket x. These operators can be nested one inside another. That means we may have a fraction in the denominator of another fraction whose square root is in the numerator of yet another fraction, and so on. There is no practical limit on this, and LaTeX takes care of sizing and placing the elements appropriately. Round brackets work normally. An example usage of mathematical operators is given in listing. Create a new file in SCITE using the File to New menu option. Type the content shown in listing in a SCITE editor. Save the file using the File to Save menu option. Now select the Tools to Build menu option, shortcut key F7 to compile your LaTeX file. If the completion was successful, you may select the Tools to Go menu option, shortcut key F5 to view the file in the default document viewer. Figure shows the output of the file when viewed in document viewer. Using equations. LaTeX provides a special equation environment for typesetting equations. Each equation is to be enclosed in the equation environment, which cannot be embedded in a math environment. Equations are numbered automatically and center aligned. Listing shows an example of using the equation environment, while figure shows a part of the output. Advantages of LaTeX. LaTeX has several benefits. Just as text was extended to LaTeX, LaTeX itself also can be extended. Anyone can create additional packages to enhance the features provided in LaTeX, to add new features, or to provide alternate implementations. Thousands of such packages have been created by LaTeX users around the world to cater to different needs. Most of them are free. They are hosted on CTAN, that is, the Comprehensive Text Achieve Network website at www.ctan.org. LaTeX is extremely good at laying out complex mathematical formula in nice looking and appropriate way. Because of this, it is quite popular among authors and publishers in mathematics, engineering, computer science, and other technical areas. Because it is open source, highly systematic, and is developed in the academic spirit of knowledge sharing and collaboration, it is popular among academicians and scholars. People in these fields use LaTeX, share their views and experiences, help one another, develop and share new packages, and drive the further development of LaTeX. LaTeX has built-in facilities to automatically update numbering and references and to automatically create table of contents, indexes, and other such needs, taking a major burden off the mind of the author.